So I've had this idea about making very tiny games, and the idea behind it is to create something so small that it's very easy to have a completed work very quickly. If you look at most of the tutorials online for games, for creating games, they're usually pretty long, like maybe 10 to 30 minutes each, and the series is usually pretty long, like 20, 30, 40 videos. And so in order for you to have a completed, game, you have to put many, many hours of work into it. So I think those kinds of tutorials are very good for when you're working on something bigger, or if you want to look at something very specific. There's lots of videos that break up what you need to learn. However, I think if you're trying to start to build games from scratch, that it's just not the best way of doing things. A better way is to just create very tiny games that allow you to build something that's complete very quickly. And what you should do with that is not only just create really tiny games, but create a tiny game that focuses on, say, a single thing. So that way you can learn something and have a nice example of something very quickly. It also allows you to iterate very rapidly. If you have a very tiny game, then you can change it very quickly because there's not much code. And if you want to try out different ideas, it allows you to try them very quickly. So that's what I want to try out here. We'll see how this goes. Maybe this will be the only video. Maybe there will be lots of them. But what I decided to do is let's go to dev C, and I'm calling these Nanogames. And the idea behind this is that the games will be so small that they're basically almost not games, but they have just enough elements that they are a game. So let's go ahead and create a directory called game1. That way it's the first one. The other thing I want to talk about is that for this, I'm going to try out Janet as the programming language. It's a Lisp-like programming language. I've been playing with it very recently, and I like it a lot. And I'm going to use the Raylib library, which can be found at, Raylib? At raylib.com. It's a very famous and very useful graphics library that allows you to do things. So I'll close a few of these things, but as you can see, I've got a few of these things brought up. It has a nice little cheat sheet, which has all of the functions that are part of Raylib. And so that's what we'll be looking at for this. And that is it. So let's get started. Also, for these videos, the idea behind them is that the games are so simple that you could actually build them with anything. So if you want to use Game Maker or Unity or some game engine, or even just another library, you can. If you want to use another programming language, you can. You can use whatever editor you can, whatever editor you want. You don't have to copy exactly what I'm doing. So I think that's kind of a nice thing that's part of this, is that I'm going to try to make it so simple that you can try it out in some other language, so you don't have to follow exactly what I'm doing. So I'm going to go ahead and create a main.janet file, and I'm going to import Raylib, and that's essentially a library that is essentially bindings for Raylib. And so since it's Raylib, I'm going to call it all RL. I'm going to create a main function, which will have args, and then we can start creating a minimal Raylib program. So what we need to do is, the first thing is init the window. So we're going to do 960 by 600, which is essentially 3 times the size of the 320 by 200 typical, old S and SNES games. We'll call this game 1, and then we'll set target FPS to 60. Then we'll have a while loop while it's not RL window should close. we will do our loop, our game loop. And what we'll do is we'll begin drawing. Then we will clear background, which will make it white. And then end drawing. And actually, that's it for that. And we'll do RL close window at the very end. So this is essentially a minimal program, and we'll expand upon this after we're done. So if we say Janet main, we've created game one. And well, we don't have game one yet. This is just a window. So let's go and make this a little bit more. So the idea behind this first game is I just want to create a little player that we can move around with our keyboard. And our goal, essentially, a game essentially has to have some kind of interactivity and then some sort of goal that you interactively accomplish. So the simplest thing that we can do is to have just a little square that we're moving around on the screen, and we want to hit a goal. So we're going to essentially pick up a coin or something. So that's what we're going to do. Is the first thing that we're going to do is build our little character that we want to have. So in order to do this, we're going to create a variable. So we're going to have, actually, before this, let's just see if we can draw a little rectangle. So RL draw rectangle. And then we're going to give it an X and a Y. So maybe 10, 50. We're going to give it a size, say 50, 50. And then we're going to give it a color and say the color will be red. Red, green, blue. And I believe that's all we need to draw a rectangle. So if we do that and we run it again, we have this old rectangle, which is kind of nice. So now, we want to be able to move this rectangle around. So we're going to give it an X and a Y coordinate. And so we're going to start it with an X coordinate of maybe 50. And we're going to start it with a Y coordinate of essentially halfway down the screen. So since the screen is 600 pixels tall, we'll take half of that, which is 300. And then, of course, the cube or the little rectangle is 50 pixels tall, so we're going to subtract half of that. So we'll have 275 pixels. So we'll say this will be X and Y. And so now we should be able to test that. And now we have our little cube. Oh, actually, you know what? Let's make this 250. There we go. So now that looks a little bit more halfway down the screen. So now we've got that. So now we want to be able to control it with the mouse, or not the mouse, but the keyboard. So we're going to do that before our drawing here. And we're going to say when, let's say key is down. Sure, we'll say key down. So when RL key down. Also, by the way, Raylib turns the Raylib functions into something that is more Lisp friendly. If you want to look at the Raylib actual functions, you can look at them on the Raylib cheat sheet here, and you can see what they actually look like, right? So for the C library and most other libraries, they'll copy the C library directly. You can see that we have a knit window, close window, and a bunch of other things. Window should close. And we're using these exact same functions. They're just mapped to different names here in Raylib. So if we look at the key down, we're going to have these mouse things. So let's actually just create some mouse values here. So we're going to say def mouse button left is going to be 0. Def mouse button right is 1. Def mouse button middle is 2. And I happen to know those because I looked those up earlier. So we're going to say Oh, we're going to use the mouse later on, but we're going to have this key. So the key, we're going to say if the key is up, and this is for the arrows. So we're going to say if the key is actually left, we'll start with left. So if the key down is left, then we're going to set x to be x minus, we'll start with say 2. And that should be okay. Oh, also in Raylib or Janet, we want to make these vars because we want them to be mutable. So definitions or defs are immutable variables and vars are mutable variables. So we're going to have those be mutable. And so that's good for that. And let's copy this and left, right, up, down. We'll say left, right, up, and down. And this will be x plus, this should be y, y minus 2, and y plus 2. Okay, so that gives us our controls. So we'll just put a comment here, user control, user control, user input. How's that? So there we go. So now that will be what we want to do. And let's just block out this drawing stuff. And actually, we'll keep this open and we'll do Janet. And we should be able to use the arrow keys. Now we can use the arrow keys to move our little controller. And maybe we'll make it just a little bit faster. In fact, we'll create a variable called speed. We'll make it 3, so it's another 50% faster. Speed. Speed. Now we've got a speed that is set. We'll test it out. Boom, we've got something that's a little faster. Now let's create a goal. So our goal is going to be var goal, goal x. And we're going to put it halfway across the screen, right? So we'll say var x, let's see, 960, we'll say, we'll subtract 60 from it. So we'll say 900. And var goal y is going to be the same. So it'll be 250. And then we'll draw a rectangle, which will be our goal. And goal x, goal y. And we'll give it a size, 50-50. And then we'll give it a color, which I believe this should be yellow, because red and green together should be yellow. And so now we should have a goal. Okay, so that's pretty good. In fact, let's just make it a little bit more dull. 0.8, 0.8. Make it look a little bit easier to see there. In fact, we can actually make the whole thing dark mode by saying 0.2, 0.2, 0.2. There, now we've got a nice little dark mode and we've got a nice little thing here. Okay, so now we've got our little character here and we've got a goal, but nothing happens when we get to our goal. In fact, we're actually going to change the order that we draw them. I want to draw our character last, which means that we draw it on top. So if I go across here, we will draw our character on top, right? Okay, so what we want to do is when our character crosses into the goal, we want to have a win condition. Okay, so now let's try to set a win condition. Check win condition. So if we're gonna look for the position of our character. So if we are within, say, 25, like half the distance, right? If we're within 25 pixels of the center of the center of that goal, then we will say that we have a win condition, and we'll print out some kind of win. So what we'll do is we'll check. We'll want to get some kind of distance. So let's write a little distance function. Define distance of xy, x1, y1, x2, y2. And we'll just calculate the Cartesian distance, which I believe, let's see, we can always use the Janet REPL here. So if we want to say, I think it's math square root of 2. All right, cool. So just wanted to check what the square root function was. So we'll say math square root, and we want to get the sum of the square of the differences between the two. So let's do a def dx, which will be x2 minus x1, def dy, which will be y2 minus y1. And then we will square each of these things, right? So dx, we'll sum the squares. So sum the square of dx, dx, dy, dy. Boom. So that gives us a nice little distance. And so then we'll say the goal center. So we'll calculate the center of the goal. So this will be var goal center x is going to be goal x plus 25 pixels. That'll be half the size. Okay. And then var goal center y is goal y plus 25. All right. So since we have just a little square there, that should be good. So now we'll check the win condition where we say if the distance, and we're going to say our x and y is within goal center x, goal center y. Oh, actually our x and y. Should we say if our, we really should say if the center of our square, right? So, so what we'll do is we'll just have, we'll calculate our center x, which will be x plus 25, and var center y is y plus 25. And then what we'll do is we'll update this with every update here, right? So we'll set, okay, there's probably a better way, or well, there's going to be a cleaner way to do this, but this will allow us to have it work. So we're going to say the distance between x and, so center x, center y. So if that is less than 25, then what we're going to do is we're going to have the winning goal condition where we say Let's see. Okay, yeah. So what we'll do, the winning condition, we're just going to go into a loop, and we're just going to print out the same thing where basically you win, right? So while not is, I think we'll say key pressed. Let's see, key pressed. Yeah, so key pressed, and we're going to say key escape. Or enter. We'll just say enter. So while this doesn't happen, what we're going to do is actually, what should we do here? Because actually, normally it should be window should close. Actually, you know what? Let's create a little variable called done. So while not done, so we'll say, so if we have the win condition, if the distance, then we should say, then what we should say is we will have RL, and then we want to draw text, I believe. Draw text. So we'll give it a text with X, Y, font size, and color. Okay, so that's what we'll do. Draw text. X, we'll give it an X and a Y, which will kind of try to get it kind of toward the center. So let's see, X and Y, we'll say 960, 450, half of 960 would be around, well, half of 900 is 450, half of 60 is 30. So that would be like 480, but we're just going to keep like a, actually, you know what? Let's just say it's 450. That'll be good for the X. Then for the Y, we'll say 300, say 275. Then we will get a font size, say 22, and then we'll give it a color, which will be green, red, green, blue. There we go. So that will draw that, and then we need to give it the text, which will be like, you win. And then we'll say, press enter. Okay, so there we go. So that gives us that, and then we'll say when that is true, and then we'll say when RL key down, enter, then set done to true. So we can only exit if we've actually finished the game. And then actually we'll allow ourselves to exit the game without finishing the game. So we'll say check, check for exit. And so we'll say when RL key down, escape, then set done to true. Okay, so I think this will be pretty good. So this will actually allow us to run our program. If we, oops. Okay, Janet main. Here we go. So let's see what happens when we get close. You win. Press enter. So let's press enter and it quits the game. So that we have actually accomplished our goals. I guess the only other thing that we might want to do is make this a little bit more centered to actually just make this a little bit more professional. We'll make it even a little bit closer than this. We'll press enter and then we'll go 400 and we'll up the speed a little bit because we don't need to make it so difficult. Okay, so we're going to go across. Boom, you win. Press enter. Excellent. Very good. So that's essentially our first nano game because we've actually done drawing, we've got a game loop, we've got a goal, and we can accomplish the goal. So that's about as minimal a game as you can actually build. And so that's pretty good. So maybe next time we'll build a little bit bigger game, just a little bit bigger nano game. All right. Thank you for watching. Until next time.